The previous video in areas looked at triangles and the formula A equals a half BH. Based on this formula for triangles, we're going to get formulae for four-sided shapes, the quadrilaterals, the kite, the parallelogram and the trapezium. We're going to consider the kite as two isosceles triangles with the same base being put together. So like that. So two isosceles triangles placed base to base, and you can see the bases form the diagonal of the kite here in red, and the two heights add together to form the other diagonal in blue. The individual triangles were half a surrounding rectangle. That was found in the first video. So it should be that the kite is half a surrounding rectangle, and the dimensions of the rectangle are its length, here is the length of the blue diagonal, and its breadth is the length of the red diagonal. So actually the size of the rectangle is the size of the diagonals. So the area of the rectangle is by multiplying the diagonals, and the kite should be half of that. So if you multiply the diagonals, you get the rectangle, and the kite's half of that. So that's kite. Here's two identical triangles. Their area here, like any triangle, half BH, and I'll bring them together. That forms a parallelogram. So a parallelogram is two identical triangles brought together. The triangles had been rotated 180 degrees. So it's two lots of a half BH. So we'd expect the area there to be BH. This case here at the bottom, this is two triangles. They've got the same height h, so they're the same height. The bases are different sizes, size A here and size B. This top triangle is obtuse-angled. Its area is a half AH, A being the base and the height here being shown externally. And the bottom triangle is base B and height H. So the same height as the other triangle. So that's a half BH. So the top one's a half AH, and the bottom one's a half BH, and they're brought together. So expect to be adding a half AH plus a half BH to make a trapezium. Trapezium is a shape where it's got two parallel sides. Different lengths, as you see. If they were the same length, it would be a parallelogram. So two parallel sides. So that's how these three shapes are going to be made up. Kites, and that will include rhombuses, parallelograms, the trapezium. So what we've got is the kite should be half a surrounding rectangle. We expect to be adding two triangles together here for the parallelogram to give us BH, and we expect to be adding these two areas together, a half AH and a half BH. Now, when I'm adding a half AH and a half BH, it's got a common factor of half and a common factor H. So you can actually factorise it into brackets, and that's what's been done here. It's been factorised. Triangles have been put together. So this one was twice a half BH. This one was half AH plus a half BH factorised, and this is half a surrounding rectangle where the dimensions of the rectangle are one diagonal multiplying the other. So that's giving us the three shapes and what should be the three formulae. I'm going to illustrate that further. Here's the kite. If you take all the air inside the kite in green and rotate it and fill up around the kite, we've now doubled the kite's area and it's become a rectangle. And the dimensions of the rectangle are the length is the blue diagonal of the kite and the breadth is the red diagonal of the kite. So if you multiply the blue diagonal and the red diagonal, that's called D1 here and D2, that gets you the rectangle, and then you half it. So that's multiply the diagonals in half, and we usually say half the product of the diagonals, product meaning multiply. So it doesn't have to be half D1, D2. It's just diagonal 1 and diagonal 2. You could call it half BH, just the same. Worth noting, one diagonal is a line of symmetry. It halves the other diagonal at 90 degrees. That is, it's a perpendicular bisector. And I want that because the kite could be a V kite looking like this. And I want to establish that if you multiply this blue diagonal, it joins two vertices here, two corners. Doesn't go outside the kite, it's inside the kite, that diagonal. And the whole of this external diagonal, D1, which goes from opposite corners. So this diagonal, multiplying that diagonal in half, the same formula applies, half the product of the diagonals. It's because if you look at this top triangle, and the bottom one's identical, top triangle, it's got a base, D2, the blue line, and it's got a height, half the red diagonal. So its area is a half base times height. It's half of half D1 times D2. So you've got to half D1 for the height of the triangle. And that'll give you the top half, and then you'll double it up because you get the bottom half. So here's what's happening. We're multiplying diagonals D2 and D1, D2 and a half D1, and then we're halving it. So that's a half times the product of the diagonal. It gives a quarter D1, D2. But then we double it up because there's two of them. So we double it up and we double that quarter to a half. So it's half the product of the diagonals. So what applied to original kite, multiply the diagonals in half, applies to a V kite as well. It's the same formula. The important thing is this blue diagonal does not involve that dotted line. That's just extended out to show it's going to make a right angle with the other diagonal. So it's the blue diagonal inside the kite from corner to corner, and the diagonal external to the kite from corner to corner. So the V kite can be awkward. Applies to a rhombus as well, because a rhombus is a kite. In the case of the parallelogram, it's simpler. The area of this triangle is a half base times height. If I rotate that triangle, I've got two of them. It makes a parallelogram. So this parallelogram is area of base times height. It's simply two triangles stuck together. There's another way to show the parallelogram, and it's this. There's a rectangle. Its area is length times breadth, but I've called the length here B, and I've called the height, breadth here H. So area of this rectangle is BH. That's its length times its breadth. If I slice down this diagonal line here and slide the chopped off bit along, it makes a parallelogram. The parallelogram must have the same area. You just rearrange the rectangle. The area of this parallelogram must be the same as the rectangle BH. Here it is, base times height. Basically a parallelogram can be considered a rearranged rectangle. A rectangle, in fact, is just a special case of a parallelogram. And finally, the trapezium. As I mentioned, there's two triangles. So if you put in this diagonal, there's two triangles. There's the bottom one in red. It's got base B, height H. Its area is a half BH. So the red one's a half BH. The top one has base A, and its height, if you extended the base out here with a dotted line and then looked at the height, it's just the same as that H. So a half AH for the top. So basically, you've got, here it is, the blue one's a half AH, the red one's a half BH. You add these together and half and H have come out as common factors into half H brackets A plus B. You add the parallel sides for the A plus B, get that answer, multiply it by the height and divide by 2. Once you see where the formulae come from, it's a case of just using them. So this is just saying multiply the diagonals in half for a kite, including the V kite, but be careful, the diagonal is from corner to corner inside the kite. It's not including this dotty bit which extends down to the other diagonal. Rectangles, parallelogram is very easy. It's just like a rectangle. It's base times height. Base and height at right angles. The trapezium, you add the parallel sides. That's what's happening in brackets. You multiply it by the height, which is at right angles to the base, and then you divide by 2. Now, it's important to make sure base and height are at right angles, just as in a triangle. It's also worth noting that the height, when we're dealing with a trapezium or a parallelogram, is just the distance between the parallel sides. So the distance between the parallel sides. There are worksheets you can get if you click the link in the description, and there's plenty of practice on quadrilaterals. There's 3 worksheets with lots of questions. Because you're only using 2 numbers in the formula, it's rather easy. So what happens is, when you're given any of the shapes, you're given extra figures, so you've got to spot which figures to use. So in the parallelogram, you've got to spot the base and the height, which will be at right angles to each other. The height is the distance between the parallel edges, and the base is always a side of the parallelogram, just as in the triangle, the base was a side of the triangle. In the kite, you're just looking for the 2 diagonals, and they're at right angles to each other. And in the trapezium, you're looking for the parallel sides and the distance between them, which is the height. So when you look at these diagrams, you're looking for the figures, 2 of them for the parallelogram, 2 of them for the kite, 3 of them, because you've got 2 parallel sides to add as well as a height, for the trapezium. So key figures are, for the parallelogram, it's this base, 7, and this height, 12. And after that, it's quite straightforward. You just apply the formula, base times height. There's one diagonal right across the kite, and there's the other diagonal, the 16 and the 21. So you multiply the 2 diagonals in half. And there's 9 and 21 are the parallel sides. And the distance between the parallel sides, the height, is 12. So you're adding the parallel sides for the bracket part. So the calculation's quite straightforward. 3 lines, 7 times 12 and 84 square units. Here, 16 times 21 and half it for a kite, it's half a surrounding rectangle. For the trapezium, you're going to add the parallel sides in the brackets first. So there's the formula. Parallel sides are 21 and 9 in the brackets. It gets worked out at 30, and then you do the multiplying and dividing. So it's just slotting them into the formula. 3 lines, including the formula. 3 lines, and that includes the formula. And here's 4 lines, and that includes the formula. So calculations are straightforward. You've just to spot the right figures on the diagrams. Not in the worksheets, but it'll be in the set of notes that goes with the worksheets. This is quite important. As here, for example, is a parallelogram. You don't just multiply 4 and 15, because the units are different. Millimetres here in the base, centimetres in the height. If you want the answer in square millimetres, you need to turn this 4 centimetres into 40 millimetres. 10 millimetres in a centimetre. And then you do the calculation. It's 15 times 40. If you wanted the answer in square centimetres, you've got to change this 15 millimetres into 1.5 centimetres. So it's 4 times 1.5 there. It's 6 square centimetres. It's hard changing the units at the end because 10 millimetres make a centimetre, but for square units you need to square the 10 millimetres to get a square centimetre. So 10 tens, there's 100 square millimetres in a square centimetre. So 600 square millimetres, you would divide by 100 to get 6 centimetres. So you don't want to be changing the units at the end. Sort the units out at the very start. If you want square millimetres, get everything into millimetres. Similarly here, if you want the answer in centimetres, you change that 1 metre into 100 centimetres. So it's multiply the diagonals in half for a kite. So it's the 80 times 100 for the 1 metre. 80 times 100 divided by 2 is 4,000 square centimetres. If you wanted the answer in square metres, you would keep that as 1 metre, and that would become, dividing it by 100, 0.8 metres. And the calculation would be multiply the 1 and the 0.8 and half. Now notice 4,000 square centimetres would be equivalent to 0.4 square metres. 100 centimetres in a metre. For square units, square that. 100 times 100 is 10,000 square centimetres in a square metre. If you divide 4,000 by 10,000, you get 0.4. So you don't want to be changing units at the end. There's no change of units here, it's a standard question. They're all in the correct units. You're doing just what you did in the last slide. You had the parallel size 35 and 15 to get 50, and then multiply by the height 10 and then half. So 3 uses of the formula. That covers the quadrilaterals. The link in the description will take you to the PDFs of these worksheets, and this one's just a straightforward use of the formulae. It's worth noting that when the diagonals are shown in the kites here, you have to show one part of the diagonal and then the other part of the diagonal, like one part's 5, one part's 10, and remember there's symmetry. This half is 4. Same, there's a rhombus, it's a kite, but with equal sides. So that's 9 is half the diagonal, this 5 is this half diagonal. So apart from that, they're pretty straightforward, and you get the answers if you get the worksheets through the link. That's one worksheet. The next worksheet is, it tells you the area, and you have to work backwards to the missing dimension, in this case the size of the diagonal. So you're working at the value of the letter, which is the missing dimension, and here these are trapezia. You've got the area given. You've got, remember, more information than you need here. In this particular question, you've got more figures than you need, and you have to work out like G or in H, the missing dimensions, and there'll be answers with them. And third worksheet's an even longer worksheet. It's got the formulae there for you. Just using the formulae, but it's got extra figures, so you've got to choose the appropriate figures in the formulae. Then you get a wee bit more complicated. There are no composites there, they're all the use of either the formula for a parallelogram or a kite or a trapezium. And then at the end, tells you the area, and you work out the missing dimension, and you get answers. Through the link you can also get the notes, which covers triangles from the last video, quadrilaterals that we've just looked at, and includes looking at the units that you've got to watch, although it's not in the worksheets. The next video will be area of circle, circumference of circle. I hope you found this video useful.